All right, we're going to keep going with our work with zero and negative exponents and look at a challenge in a real-world connection. I encourage you to pause the video, try these on your own, and then check back in and see how you did. So let's do the challenge on the left first. That looks kind of nuts, honestly. So let's simplify it as much as we can first inside the brackets, and then we'll deal with the -1 exponent at the end. I don't really want to deal with that right away. So let's do some simplifying first. Some things that look like can just go to 1, and so those two things go to 1. And then separately, it looks like this can be flipped down below, okay, because it has a negative exponent. So let's do that. So this turns into 3 over t squared plus -4 over t squared. And I think maybe you'll notice right now that we got lucky with some common denominators. So that was kind of nice how that worked out. So we can add those fractions together right now. So this is going to end up being 3 minus 4 all over a single t squared, and then raised to the -1. 3 minus 4 is a -1, so -1 over t squared, again raised to the -1. So let's apply that -1 exponent. We get t squared over -1, which is just going to turn into a negative t squared. And that would be our final answer. It's nice how things simplify so much sometimes. All right, next one, the real-world connection problem. And this is sort of partly real-world, partly has a little bit of contrived stuff to it. You might not get 3.5% growth per year, and you might have some compounding happening also, but we'll look at that in a later video. But for now, let's go with it. Invested in a savings account, a principal of $100 might grow at 3.5% per year. Following the equation below, determine the value after 20 years. So a little bit of info for you. This 100 is our principal amount, our starting amount of 100. And this 0.035 is 3.5% converted to a decimal. And then we just need to add it on to a 1, which is a whole or 100%, so that we're actually growing. So we're keeping our initial 100% of our principal, and then we're adding on 3.5% to that. So that's why this is a 1 or 100% plus a 3.5%. Okay, but let's go ahead and run the numbers. We get 100 times 1.035 to the 20, and that's something you definitely want to do on your calculator. You're probably going to use maybe a y to the x button, or maybe this caret button, depending on your calculator you have. Okay, so I'm going to run it through mine here. Raised to the 20, and then times $100. And I get an answer of $198 and rounding to the cents, 98 cents. By the way, I don't know if you overheard me when I was sort of speaking through using the calculator, but I put this into the calculator first. And that's because I knew that exponentiation happens before multiplication. A sophisticated calculator should let you put it just all in left to right, but I think it's easier for me to just think about what do I type in first, rather than do I trust the calculator to really carefully follow order of operations. So once again, I put that highlighted stuff in first. I do the exponent first, and then I multiply by 100. All right, so here's our final answer here. Look at that, we almost doubled our money just for letting it sit in the bank for 20 years. Okay, that's a good place to stop.